Hello, everyone, and welcome to All Things Hacked, where we hack everything from the laws of nature into the laws of your locker. And in today's episode, we are going to look at the reason, in terms of physics, why an object in physics cannot eclipse or equal the speed of light. So, uh, greater than c. C in physics represents a constant speed of light. So, can anything travel faster than the speed of light, or even equal to the speed of light? According to Einstein's theory of special relativity, he postulated that the speed of light is a fundamental constant of nature. It appears the same to all observers anywhere in space. Further, that same theory says that objects gain mass as they speed up, and as they are speeding up, they require more energy. So essentially, as an object goes faster and faster, it gains mass. Also, it requires more energy as it's gaining mass to go faster and faster. And essentially, as it equals c, equals the speed of light, its mass becomes infinite, and therefore its need for energy becomes infinite, which in physics speak means that the laws of physics, the equations that govern classical mechanics with Einstein and special relativity, break down. Now, you probably heard that also. Why can't it? Oh, it breaks the laws of physics. But what does that mean, it breaks the laws of physics? Now, the laws of physics are generally mathematical equations. And, some of the simpler one, not simpler, but one you may be acquainted with is Einstein's own equals mc squared. Now, this is a good example because, one, it carries the constant c, which is the speed of light. And it's something you've all been acquainted with, and all the elements or items within this equation are something you should be familiar with. You have E, which represents energy, M, which represents mass, and C, which represents the constant for the speed of light. And really all this equation is doing is showing you that the amount of energy within a given mass is very large. So, to discover how much energy is in a mass, you have to take the mass and multiply it by a factor of c squared, which in nature c is a very large number. So all this equation is doing is showing you that there is a great deal of physics. There's a great deal of energy in mass. Atomic bomb speaks volumes to this. A small amount of material in an atomic bomb, but a great deal of energy. But discussion for another time. So, again, laws of physics break down. Laws of physics are mathematical equations. How can we demonstrate that? So we can take these words, laws of physics break down when objects travel equal to or greater than the speed of light. How can we see this? It's all been said to you, and you probably you've all probably reasoned it to be true, but you may not have actually been able to ever see why it's true. How does a law of physics break down? So I've chosen a specific scenario to demonstrate and give you a real equation, a real law of physics, and break it when a velocity of an object is equal to or exceeds the speed of light. And I've chosen, again, this is somewhat complex, and we're only going to look at a tiny little piece, and you really don't need to understand the context of what we're going to speak about, but we're just going to show you an equation that is true in physics, and we're going to break it. So we're going to focus on what's called the Lorentz transformation, which is named after a Dutch physicist. And the transformation describes how measurements of space and time by two observers are related. They reflect the speed of an object at different velocities. So essentially, as a velocity of an object approaches or gets closer and closer to the speed of light, what happens in two frames of space, or two by observers of the same object. What we're going to key in on is what's called the Lorentz factor. Now, the Lorentz factor is also known as the gamma factor. Now, again, we're not going to get too concerned with what it does or what it means. All I'm going to say is it yields a specific value when true that is used in some of the classical mechanics of physics. So the Lorentz or gamma factor is the variable gamma is equal to 1 over the square root of 1 minus v2, the velocity of an object, squared, over c squared. And essentially, while v is less than c, this equation yields an actual result. So as long as the velocity of an object is less than c, this factor, this gamma factor, part of the Lorentz transformation, yields an actual quantity, an actual physical number of some kind that can be used in applications and other equations to solve problems, predict, give evidence of the nature of physics. So it's actually a perfect way to see how a law of physics will break when a velocity of an object, or the speed of an object I should say, is greater than or equal to the constant c, the speed of light. So we're going to break this equation, and you can see, if you have any sort of math, you can see that as long as v is less than c, the value of this term will always be positive, and therefore 1 minus this positive number, it'll be positive and it'll be less than 1. So it'll be greater than 0 and less than 1, the value of this term here. And as long as it is, this equation will yield a result. So let's break it now and see what happens. So, how are we going to break it? We're going to break it by letting the velocity of the object equal c. So in this case, we're going to have gamma is equal to 1 over the square root of 1 minus. Now, for the purposes of this demonstration, what I'll do is since they're equal, I'm just going to arbitrarily assign them a value of 1, so it really doesn't matter, and then I want to run out of space. So if I say v is equal to c, I can just say both are equal to 1, and what I'll get is I'm going to have here is 1 over the square root of 1 minus 1, which is the square root of is 1 over the square root of 0, which effectively breaks this equation. So we can see how we took a law of physics and we demonstrated when v, the velocity of an object, is equal to c, a fundamental, not fundamental, but a valid law of physics, an equation of physics that's used in many different aspects, breaks down. Previously, on this side of the board, it yields a value, a result, something that can be used. When it's equal, the velocity and c, it breaks the equation. You get this 1 minus 1 in the square root, and you get 1 over the square root of 0, which is blah, which is nothing. So now let's do where v is greater than c. And I'll arbitrarily, again, assign it some values just for the purposes of demonstration. We have gamma over the square root of 1, and I'm going to say v is equal to 2, and v squared is equal to 2, and c squared is equal to 1. And so it's just demonstrating that v is greater than c, and we're going to get 1 over the square root of 1 minus 2, which is equal to 1 minus over the square root of minus 1. You cannot take square root of a negative number, and this equation has been broken as well in this manner. So we can see, and that's all I really wanted to demonstrate, was we take a legitimate equation in physics, part of the Lorentz transformation factor, which examines an object's velocity and its effect on physics as it approaches the speed of light, see, and we can see in an equation, an actual equation that most people cannot understand, myself included, and we can actually see it break. So you can see what it means to break a law of physics, an equation of physics. So it's not often that you can say, hey, I have a notion going faster than the speed of light, and then I can demonstrate in an actual physics equation it breaking. So that's all I really wanted to show you. If you enjoyed it, thought it was marginally funny, thought I could improve it, leave a comment, hack that like button, hack that favorite button, hack that subscribe button. Peace.